Alright, so today I wanted to just record something to tell you a little bit more about air pressure and weather patterns, because I remember when I was growing up and learning this, it was rather confusing for me because it's not something that we can actually physically go outside and test, so to speak. So I used this a couple years past. It comes from the book. The page numbers aren't exactly the same, but some key things to remember: that air pressure, okay, is the weight of the atmosphere on Earth's surface. So obviously the higher up we travel, there's less air pushing down on us. The lower we go, the more air pressure we feel. The differences in air pressure cause air to move. And we know that temperature can affect air pressure, whether it's hot, whether it's cold. In cold temperatures, where our air particles move closer together and sink, remember we talked about when things are colder, they're more condensed, tightly packed. So since it's heavier and denser, it sinks. And that's when we say that there is a high air pressure system, because it is densely packed, it is pressing down. Whereas warmer temperatures, air particles are moving apart. They're rising, if you've ever heard the saying, heat rises. So then the air pressure is low. There's not as many air particles pressing down. An air mass is a large body of air with the same temperature and moisture properties. So it's not just one particle of air, it is the big body of air, a large air mass. And I wanted to just briefly cover what that exactly means, because depending on where we're located in the United States, you'll see this chart here, we have different types of air masses based on its temperature, we see hot or cold, and its moisture, warm or dry. Now, if we're looking at air mass A, if we know what lies directly north of the United States, we know that that is Canada. Since Canada is actually a land mass, that would mean that that the air traveling would actually be dry. It's not picking up any water molecules as it is traveling over, over land. And if I were to draw, so if it's traveling this direction, we can see that it is coming off of land, so it would be dry. Now, thinking about where Canada is located in relation to the equator, it is relatively further north. That is what's going to help determine its temperature. In this case, since it is so far north, that would then have this air mass would then be cold. So if it was coming from the north above on land, we would have a cold, dry air mass. Now, using that knowledge, if I were to look over here at air mass B, and we picture where these are coming from, excuse me, I'm trying to draw it here. It's coming this direction. I want you to take a minute. Do you think if it's coming off the coast of, say, California and Washington, is that going to be warm or dry? Excuse me, I should say warm or wet or dry. My apologies, not warm. Okay. So, coming over from the ocean, that tells us, again, I apologize, it shouldn't say warm or dry, it should say wet or dry. Okay. Being that it is coming from the Pacific Ocean, that would have a lot of moisture. We'd be picking up all of the water droplets and molecules from the Pacific Ocean. And again, based on where it is coming from, further north, that would also be a cold air mass. Excuse me, I'm still trying to learn this program. Good, it will let me move it. All right. So then C, this is very applicable because of where we live. And most of the times when we have air masses traveling our direction, again, think about where it is coming from. In this case, the Atlantic Ocean. So the moisture level here, it would be very wet. But now, thinking about where C is located, it's definitely not as further north as A and B are. So this air mass would actually, since it is forming over what we would call kind of tropical areas, that would definitely be a hot or a warm air mass. Anytime it is traveling near the equator, okay, this is key. If it's coming from near the equator in our tropical areas, it is definitely going to be a hot air mass. So that being said, if we look at D now, and picture those air masses traveling, okay, we just discussed that if it is coming from areas further south or closer to the equator, that we would have a hot air mass. However, now the difference is, if you picture, now I know this map does not have it, but right there at the base there with Texas, we don't have a body of water, we actually have Mexico, which is, since it is land, is that going to be dry or is that going to be wet? That is going to be another dry air mass. I'm trying to just move it here. Oops. Okay, so hopefully having this visual will make it a little bit easier. I know that come Thursday, when you take the quizzes online, there are quite a few questions about what type of air mass could we expect if it is forming over tropical waters. Well, we had said if it's coming from tropical waters, so if we were to kind of summarize here, okay, from the tropical areas, it's definitely going to be warm. If it is traveling from a more polar region, further north or south away from the equator, it will definitely be a very cold air mass. If it is traveling over land, we said that would bring dry air masses because it's not picking up any water molecules. So if it is coming from a body of water, that would then leave it to be a wet air mass. So hopefully this was a helpful guide. If you are given a photo, you should be able to determine whether or not that area would have a warm or cold or dry or wet air mass traveling around, and that is how we can predict the weather at a given place or time.